Assalamualaikum and good afternoon to Sir Azdi. Today, me and my partner represent you our project, which is weight are to be related to blood fat content by using the least square solution. My name is Nur Diana and my partner is Nur Isha Natasha. Let's proceed to the next subtopic, which is the introduction. Because of mechanical and hormonal factor, being overweight or obese can induce high blood pressure. However, being overweight or obese can alter blood fats such as cholesterol and triglyceride, and putting your heart health at danger. In this study, we would like to see if there is predictable relationship between weight and blood fat content. And for this study, the least squared solution method will be used. Least square solution method is a form of mathematical regression analysis used to determine the line of best fit for a set of data and providing a visual demonstration of a relationship between the data points. This is the secondary data we obtained, which is weight and blood fat for 25 respondents. Least square solution of linear system. The least square approach involving minimizing the sum of the square of the offset, which is residual components of the points from the curve to get the best fitting curve or lines of best fit for a group of the data points. The trends of outcome is statistically estimated throughout the process of determining the relationship between the two variables. There are three types of model used in this project, which is the linear model, the quadratic model, and the cubic model. For the linear model, first we must set up the MV equal to Y, where M is weight in kg while Y is blood fat content. Then we can construct its normal equation. Then we can obtain the least square solution, which is 199.2975 and 1.6223. After that, we can find the error of magnitude for this data. And from the least square solution, we can obtain the fit linear curve, which is y equal to 199.2975 plus 1.6223x. And from the error, we can find the error magnitude, which is 367.6212.
Next, let's test our data into quadratic model that is degree of 2. First, as you can see here from the slide, first we will set up MV equal to Y, where M is equal to weight in kg and Y equal to blood fat content. That is our data. And we put this data into the matrices. As you can see here, left side of our matrix is 1. The first column is 1. Second column, we put the value of x, and the third column, we put the value of x power of 2, and then multiply by A, B, C, D, that is represented by V, equal to y, that is our data of blood fat content. Next, we will get the normal equation, as we can see here, and then we will calculate the least square solution. Next, we will get from here, we can get the error of vector that E equal to Y minus MV1. As we can see from here, then the best fit we will get the best fit linear curve, that is Y equal to 334.9266 plus 7.306 x minus 0.0464 x power of 2. Therefore, the magnitude of the error that actually we will looking for is 361.7318. And as we can see here, after we plotting the graph using our software here, we can see that the graph showing the quadratic graph here. Next, we also test our data into the cubic model, that is degree of 3. As usual, we will set up MV equal to Y, and as we can see the data put into the matrix. At first, the first column is we put all of the number is 1, and the second column we put the value of x. third column we will put the x power of 2, and the last column we will put the value of x power of 3 as a cubic model, degree of 3. And from it we can get the normal equation as stated in the slide. And after that we'll get the least square solution. A equal to 540.2644, B the value, C the value, and D the value. And after this we will get the error of vector, that is as stated earlier, E equal to y minus mv1. Okay, and then we will get the best fit linear curve, that is y equal to 540.2644 minus 24.1704, x plus 0.5327, x power of 2 minus 0.0033 x power of 3. Therefore, the magnitude of error vector that we are looking for is 356.689. And as usual, we can see from the graph that we are already plotting, this is showing the cubic graph from this equation and the data that we also put in the graph. Based on the model above, the following error magnitude in the approximation are obtained. For linear best fit curve, the error magnitude is 367.6212. Next, for quadratic, the error magnitude is 361.7318. And lastly, for the cubic best fit curve, the error magnitude is 356.689. As we can see from the table here, the least value of the error magnitude is holds like cubic best fit curve, and the value is 356.689. that is differ and less than the linear and quadratic best fit curve. So we only stop at the cubic best fit curve because we already found that the cubic best fit curve is already less than linear and quadratic. Lastly, the conclusion. Therefore, the best fit curve in this case, which will give the best approximation, is cubic best fit curve because it has minimum error magnitude as we stated earlier. So this is the graph of the cubic best fit curve. That's all from us. Thank you.